Hello, hello. Welcome to the Future City Eye on Engineering webinar. We're very excited to have you join us. Before we get started, could I get just a few people to click on the raise hand button on your webinar control panel, just so I can be sure that you're all able to hear me. It's just the button. Great. Thank you. Thank you. Excellent. Michael, thanks. Excellent. Well, welcome to the Future City Headquarters' first ever Eye on Engineering webinar, which is especially for students. My name is Jake Williams. I'm the program coordinator for the Future City competition. Also on the line is Future City program manager, Maggie Dressel.
Hi, everybody.
That's Maggie. And before we get started, just a couple quick technical things to get out of the way. The platform that we're using at the moment is called GoToWebinar. If the sound quality is not great for you, you can dial in on this teleconference line, the 415 number. So you can just either take a screenshot or write that down in case you need it. The access code is there, and you'll get the audio pin after you join the webinar. A recording of this webinar will be posted on the futurecity.org resources page in the next few days for those who were not able to make it, or if you were able to make it and would like to see it again or review a part of it, it'll be up in the resources section. How to ask a question. So as you may have discovered already, you're not able to talk, you're on mute as an audience member, but you can type your question into the space on the webinar control panel that allows for questions. You can type a question throughout the presentation if anything comes up, and we'll pose as many of them to our panel at the end of the webinar as we can. So if while you're hearing anybody talk you have a question, you can just type it on in, and hopefully we'll get an answer at the end. So what is this webinar? Whether your team has already started on your project or you're just getting ready to begin, understanding the principles of engineering is going to be something that will help you in all aspects of Future City, in addition to all aspects of your schoolwork and just life in general. It's very useful things to know. Our presenters today are each from professional societies that take a lot of pride in the work that they do, and therefore they each sponsor a special award at the finals competition. Both Future City finals and many regional competitions have special awards for teams who meet the criteria determined by each sponsor. So you can check with your regional coordinator to find out what special awards are offered at your local competition. Because engineering covers such a wide variety of fields, we wanted to gather together 3 different types of engineers, so they can tell you a bit about what it is that they actually do. So joining us today is Scott Bishop and Brad J. Roberts from the National Council of Examiners for Engineering and Surveying. We also have Victoria Valentine of the Society of Fire Protection Engineers and Charles Hochstein of the Institute of Industrial and Systems Engineers. So we're going to start off with the National Council of Examiners for Engineering and Surveying. Scott Bishop has over 17 years of experience as a land surveyor in both the public and private sector. He served as an expert witness on multiple cases and has also served as an acting city and county surveyor. Scott is currently the chair of the Utah Professional Engineers and Professional Land Surveyors Licensing Board. He has a BS in geomatics and was the 2015 Utah Council of Land Surveyors Land Surveyor of the Year. Also joining Scott is Brad J. Roberts, who's a licensed professional surveyor who's been practicing since 2013. He's a supervising professional land surveyor at Sigma Consulting Group in Baton Rouge, Louisiana, where he's worked for over 9 years. Mr. Roberts currently serves as the District 6 Chairman for the Louisiana Society of Professional Surveyors. So Scott and Brad, thank you so much for joining us and welcome. And could you please tell us a bit about surveying?
You bet. Thanks, Jake. We appreciate this opportunity to talk to you and everybody about what surveyors do and part of the greater role about what NCES, or the National Council for Engineers and Surveyors, does. Again, surveyors, BJ and I are just two great little surveyors, but NCES is very keen on promoting licensure, and they're the people that are responsible to help individuals to become licensed as surveyors. So BJ and I want to talk just briefly about some of the things surveyors do and how it may relate to this. If you want to jump to that next slide, Jake. Surveyors do a lot of different things. One of the things that are predominantly they do is we measure things. We mark. We can go out with all different types of equipment, and we'll talk a little about through the day-to-day. We kind of laugh here in my office that the surveyors have the coolest tools of everybody in the office. We get to go out and play with a lot of toys, and we use those toys to determine the locations of things on the Earth's surface. Everybody's probably used Google Maps or something with their car to figure out exactly where they're at, but surveyors need to know a little bit more accurately where things are located. So that's one of the things that surveyors do. On a pretty regular basis, we'll take that information that we use all of our cool tools to gather, and we can send it out to a lot of different places. A lot of engineering firms will use that information. Contractors, construction people will use it. Property owners, if you ever wanted to know where your property was, if you wanted to build a fence or just want to know how much property you actually own, if you want to create a subdivision, you would need to hire a surveyor to help you do all those things. BJ, is there anything else you want to add to that?
No, that all sounds like you've got us in a nutshell. I would like to add that I'm honored to be a part of this webinar, and Scott and I came up to do the surveying special award for Future City last year, and we were super impressed with the whole thing. I mean, everybody did such a fantastic job, and definitely have to thank NCs for giving us the opportunity to be a part of this. So far, what you got, Scott, seems spot on, and if you want to skip over to the next slide, we'll kind of talk about some of the fields of surveying. You'll see the tiles here: forensic surveying being, just that. You might do some accident scene reconstruction, something of that nature. And I apologize for the background noise. We talk about this kind of being a hybrid of field and office mix. I'm actually in the field right now on my laptop doing this webinar. So you kind of get that mixture of being in the office but also being in the field, and that's just one of the pluses to being a professional land surveyor. Back to forensic surveying, accident scene reconstruction, foundation settlement investigations, things of that nature, crime scene investigations even. You may see some of your local law enforcement out there with some of the technology that land surveyors use on a daily basis, taking measurements for accident scene or crime scene investigations. We do storm damage assessments. Anytime there's this big natural disaster, you always see this influx of work for professional land surveyors, and kind of assess the needs and how these disasters have affected local areas. Geodetic surveying is kind of the surveying and mathematics concerned with determining exact positions with corrections being made for the curvature of the Earth's surface. Construction surveying, or you guys may have heard of layout. That's where we lay out reference points and marks that will aid and guide construction of new structures or improvements. GIS being geographic information systems. That's utilized to store, manipulate, maybe manage and analyze data. Photogrammetry it kind of breaks down the word itself, meaning picture measurements, right? So it's the science of obtaining information through imagery. specifically aerial imagery. I mean, you guys have probably all seen, an aerial map, via Google or Apple Maps or something of that nature. Hydrography, the measurement and description of physical features of water bodies, and with the measurements of those water bodies, you can use that data to predict their change over time. Topographic surveying is used to identify and map contours of the ground and existing features on the Earth's surface, or even slightly below the Earth's surface. And then we've got boundary surveying, and that's kind of a big one for me. That's what I practice most in, and that's determining property lines and defining property corners of parcels of land. And these couple of things that we show here, these 8 areas, and we're probably missing a couple. It's a multifaceted profession that I can tell you I've been impressed and very fortunate to be a part of. Scott, what are your thoughts?
Yeah, no, like I say, as BJ mentioned, there's a lot of different areas, and one thing that's kind of neat about being a surveyor or doing this is most surveyors do multiple of these. There's a few individuals that maybe are just really kind of specific to one of these areas, but most surveyors kind of cross and do. They may enjoy one aspect of surveying a little bit more than the other, or do more of it, like BJ said, with the property and boundary. But they get to kind of do this wide range of things. Another item that kind of that's kind of close to home to a lot of people right now is probably flood certification and elevations, to make sure if there is floods that your house or your property will be above that. Surveyors would go and determine that flood elevation height, and obviously with some of these storms we've had, it doesn't matter how high or what would have happened. And then some of the great things that we get to use to do these things, that I'm sure everybody's pretty familiar with virtual reality. Surveyors kind of take that real world. We can go out there with all these different types of tool and collect this data. We call it a point cloud, and it really creates a virtual reality that's real. And you can go ahead and put a project like a new highway or something into the existing world, and everybody can kind of see how it's going to fit. So we want to talk to you just a little bit, Jake, if you can jump over another slide about kind of what a surveyor would do each day. And like BJ said, he's out in the field, and I'll let him kind of tell you what he's been up to today. I'm currently sitting in my office. There's a little bit of snow on the mountains out here. It's kind of a cold day, and so I had some meetings this morning, so I decided to stay in the office. But surveyors, like I say, as BJ said, it's kind of this field and office. I enjoy it because there's a lot of history, a lot of detective work, trying to figure out what people have done before me, what their intentions were, why they did what they did. We get to be kind of the first ones and last ones there. As we talked earlier, we get to go out and gather the data and the topography and figure things out. We get to help with the planning and the zoning and the layout of how things should be set and where. And then we're kind of the last ones to get out there and lay that back out, that construction or layout surveying, to put it all on the ground. And as I've mentioned several times, I'm kind of big on the technology that we get to do all sorts of great things. We've got, my firm, we've got boats, we've got drones, we've got airplanes, we've got scanners and GPS and traditional survey stuff. And of course, we all have a tape measure and a compass. But it's kind of neat. We're kind of on the cutting edge of technology and get to use these different things and stay up with them and be kind of current. So, like I say, I've been in the office in the computer all day today. BJ, what have you got going on down there in Baton Rouge today?
So I've been about, I'd say about 4 hours from home, working out of town a little bit. We're creating conservation easements right now for the Wetlands Reserve Program, which is a great program through the federal government, and we get to go out and talk to landowners and talk to district conservationists about creating this easement for the Wetlands Reserve Program and how it's going to positively impact native species habitat and this kind of thing. And like Scott said, I mean, the technology is second to none, and it kind of depends on what firm you're at. I know Scott's operating with a little bit higher technology than what we operate with here in Louisiana, but you get the opportunity to really touch on some amazing pieces of equipment, and they're all tools to help you arrive at that destination or your final product. Jake, you want to flip over to that next slide? We'll talk a little bit about using surveying in everyday life, and you may not even realize that you're using surveying when you give someone directions to a particular place. I mean, that those directions are some bearing and some distance, right? Like you're giving them a heading and a distance to get to a certain place, or you read directions from Google Maps or something of that nature. Measuring now, I mean, that's essentially what we're doing. We're taking measurements on the Earth's surface, and we're making maps and providing information to engineers for design. And we've all seen guys out there with GPS, and that's kind of been this huge boom in the last 15, 20 years. This GPS has really improved and gotten more accurate. And I mean, I don't know, I might date myself a little bit here, but the first iPhone came out, and you could look at the GPS feature on the iPhone on the maps, and your little blue dot kind of bounced around a pretty good bit. You knew you were in your house, but that dot was bouncing around. And as we got further down the road, that little blue dot kind of zoomed in right on us, right? And that thing only bounces around a little bit now, and technology is increasing, and as technology is increasing, the tools in land surveying are increasing, and we use these tools for planning and land development, and as Scott mentioned before, creating subdivisions, doing layouts of improvements, structures. Really all of those things are kind of under the umbrella of the professional land surveyor. It's been very impressive to me, just the how big the umbrella of land surveying, how big that umbrella is, and what all we encompass, and what, as a profession, what we're needed for. So I've really enjoyed it. Scott, what do you think?
And just the last thing, and then we'll let some of the other folks have a chance here. Surveying is really helping everyone that wants this dream to own land and own property. You got to know where it is, and so we can talk about directions and measuring, but one of the greatest thing anyone ever has is their property, what they own, and a surveyor is who tells you what you own and actually places that on the ground. So it's used whether you want to get somewhere or put your fence in or know what you've got. But we're excited. We enjoyed being out in Washington, D.C. last year. Looking forward to it this year. And if you have any questions after everybody else is done, we'll hang on the line and be glad to answer any questions. So appreciate it. Thanks, Jake.
Yep, thank you, guys.
Great, thank you, Scott and BJ. Really appreciate it. It's really interesting to hear. As I mentioned, if anyone in the audience has questions about surveying, you can type them in now. We've already got one, and then we'll give those questions to the presenters after everyone has all three presenters have gone. So our next guest is Charles Horstein. He's the lead contracting officer for cybersecurity for the U.S. Postal Service. His team is responsible for the sourcing and acquisition of the security software and services that the Postal Service use to secure and monitor and protect its IT networks. Prior to joining the Postal Service, Charles worked as a manufacturing design engineer, a systems test engineer, and an in-plant quality assurance manager for PC-based systems, both domestic and foreign distribution. Charles?
Yes, thank you. Good afternoon, folks. Glad to be with you. The first question that comes up is exactly what does an industrial, if you would, a systems engineer do? I'll give you a second to read the official definition there. As you read that, the key things you might want to take away is the interesting facts on the right. We're a diverse group of people. We've led organizations because we're interested in how organizations work. If you take a look at the classical titles that industrial engineers fulfill, you'll see we're often called industrial engineers, if you would, manufacturing. We're called systems engineers because we're interested in how things go together, quality. If you take a look at all these terms, what that basically tells you is we're interested in how the parts fit together. Sometimes you might remember of an old slogan Monsanto had, we don't necessarily make things, we make things better. We're interested in how the different parts fit together to reduce waste, to make things more efficient. So we depend on scientists to figure out the chemistry or the physics of how something works. We depend on many other engineering disciplines to figure out exactly how to put things together in terms of their design. What we're interested in is how they fit with everything else so that they work efficiently, whether that be in a manufacturing environment, a production environment, a football team, whatever have you. Let's take a couple of looks at let's take a look at a couple of examples, if I may. Slide, please. Am I here? Thank you. First one in the upper left is kind of what I do right now. It's kind of exciting. What I'm doing, what my team and I are doing, is we look around the world where we can buy software, services, appliances that best secure IT networks. We find out where they're made, how they're designed, how they're tested, how they communicate, where they can be installed, what the cost buildups are of everyone who touches that, and how we can integrate that into a system to efficiently provide, in my team's case, IT security. Next time you go to a post office and you want to know who's making sure your credit card data isn't being stolen, I'd like to think I have something to do with it. Another fun example of how you take a systems approach is in the lower left-hand corner. This is actually kind of a more traditional IE function and has to do with a discipline called ergonomics. As you move in a manufacturing plant, as you move to accomplish a task, your motion can dictate whether you get hurt, whether you're efficient. If you use your arm correctly, you can throw a ball more effectively. If you bend over and pick something up the wrong way, you can hurt your back. So one of the things I always look at is using ergonomics and the tools of system integration, how we can help people to move more effectively as they're going about their daily work to be both more efficient and reduce the injuries. Another example in the upper right, something I had fun with years ago, was actually how do we put conveyor systems, robotics, manufacturing, how do we get all these other things that people have made and designed to work together to build a product efficiently, reliably, with a high quality level. Design of advanced manufacturing systems, a very core thing that many IEs do. Again, in the lower right, if you look at a systems approach to power, IEs don't necessarily build those generators. We don't build those towers. But we are interested in how everything fits together as a system and how that data can be presented. Next slide, if I may. A fun one for all of us in the upper left. A core IE function, if you're going to know how a system fits together and how to make it work efficiently, a key task is what we call queuing theory. As the name implies, what we're looking at is how people arrive or equipment arrives at an event, how it gets served, and how the needs are met. That could be at a bank, that could be at your grocery store. For those of us who like to visit Disneyland, I assure you, Disney uses a great number of IEs to figure out how to staff, how to organize their rides, so that as people show up, they have the least waiting time given the number of people at the park. Bank tellers are the same thing. How many bank tellers do I need so that the customer doesn't get discouraged and leave? How many tellers do I need at a grocery store to make sure people aren't waiting in line too long? Queuing theory. How to make the system work so that the customer is happy. IEs have recently been spending a lot more time, as we see here also, in the medical world. It's becoming a larger and larger part of our economy, both because our capabilities are increasing, thank you to the scientists and doctors, but also, folks, we're all going to live longer. That's the good news. The bad news is it's up to each of us to learn how to do that better. So what IEs are interested in doing is how to set up the systems to make sure the doctors in the clinics have the tools clean, ready, and able to be used when they need them. How do we make sure that all their diagnostic equipment is ready? It's called metrology. Make it measured correctly and ready for use. How do we make sure all those wonderful prosthetic designs that our biomedical engineers are coming up with can be made efficiently, effectively, and be ready for the person who needs them when they need to repair what in this case was obviously a rather debilitating injury. So if we could, that's what industrial engineers do. We're interested in making things better. We're interested in finding out how the different parts fit together, how they can be fit together better, how can we help the people who are doing the work do it more efficiently, how do we drive waste out of the process. Let me tell you, it can be fun. As the narrator here shared with you, I'm arguably on my third career. It's a blast. First career, designing manufacturing. I pointed that slide out earlier. How do you build something that people want with cutting-edge technology? I had the privilege of playing with some of the most advanced IC circuits and printed circuit board designs to build computer systems in the 80s. Sorry, I am that old. Goodness, I had stuff in my hands that most people hadn't seen in the store yet. We were making new computers the world had never seen. Okay, I then moved on from designing it to actually being a quality manager in a plant. Helped build one of the first video conferencing systems ever sold. Today we Skype, we do all this, we think it's de rigueur. As an IE, I had a privilege of being there when the technology was being first developed. Today, I have a group of colleagues and I literally keep the Postal Service's IT network secure. We work with a supply base and a group of IT professionals here to make sure the right products, the right services, and the right appliances are in the systems at the right point in time. We're trying to make sure one of the country's largest and most trusted organizations remains free of some of the debilitating effects of cybercrime. That's my story. I've shared some other stories with you. I'm here to tell you it's exciting to be touching the cutting edge of things and learning how to make things better, faster, easier to use, and more effective. As a group, our society is called the Institute of Industrial and Systems Engineers. We're headquartered down in Norcross, Atlanta, Georgia, and we promote our discipline throughout the country. Thank you for listening to me for a few minutes. I've had a great time being an industrial and systems engineer. Think about it. You may be too.
Great. Well, thank you very much, Charles. Very interesting. Great to hear. Our final speaker of the day is Victoria Valentine. She is the Director of Professional Qualifications and Industry Alliances for the Society of Fire Protection Engineers. She holds a BS in Civil Engineering and an MS in Fire Protection Engineering, both from Worcester Polytechnic Institute. Victoria is a licensed engineer who has expertise with fire sprinkler systems and earthquake protection for mechanical systems. Victoria, can you tell us a bit about fire protection engineering?
Absolutely. Thanks, Jake. I echo some of the other speakers in that it is great to be here. I know how impressed we all were with last year's competition, which was my first involvement with Future City. But I'm really here to tell you about fire protection engineering, which often is one of the engineerings that people don't even know exists. So it's good to help and get some information out there. Jake, are you changing the slides? Is that how we're going here?
Yep,
okay,
that's right.
Great. So SFPE is the Society of Fire Protection Engineers. We've been around since 1950, so although we do have quite a few years experience, we are one of the younger engineering groups that's out there. So let's go ahead and move on. So just to think about fire protection engineering, and I threw a shot that I took actually at the Boston Harbor when I was up there for a conference not long ago, in that fire protection is one of the fields that really crosses just about all aspects of the built environment. So we're looking from initial construction across the lifespan, what materials we're putting in the buildings and how does that impact our overall fire protection, how to work with the civil service, including our fire service that actually responds when there is an event. And it can cross everything from vehicles to buildings to ships. So we find fire protection engineers in a multitude of avenues. There's even some that are a little bit more unique. Anytime you see some of the larger pyrotechnic shows, there's usually fire protection engineers involved in getting those to operate. So a lot of different fields, but we are going to talk about some of the more major areas as we go through this. So we'll start with research. So obviously, today's world, we come through academia, and there's always a lot of research tied to academics, but there's also just a lot of research that goes on in order to put products on the market. And so what I tried to do here was actually give 3 different scales of testing that we see and do that help us to learn how to keep a fire-safe world moving forward. So everything as small as candles, and they work on these very small scales to try to develop new ways to control a fire or to eliminate a fire. And one of them that I think has been one of the interesting research pieces that keeps popping up here and there, although they have not necessarily come up with a real commercial application, is to do sound waves. And that the sound waves can actually disrupt the flame and get it to extinguish. In the center picture there, you see a crib fire test that's used in residential fire sprinkler testing. So it's what I'd call like the middle scale. It is an 8-foot ceiling that you're looking at there from where the fire is to the top of that board. But that's just a designed schematic so that it's a repeatable test. But there are engineers throughout all of this in order to develop these tests, in order to analyze them, and determine how we take this information and then apply it to the actual real world. Now the one on the right is actually a plastics fire. So, and just to give you a little perspective, the ceiling in that picture is actually at 20 feet. So again, you know, all sorts of levels for that particular test. There was testing being done on a dry pipe sprinkler system, meaning there's no water in the piping initially until the sprinklers actually operate. But lots of research done. Some of the bigger institutions are NIST, the National Institute of Science and Technology. Underwriters Laboratories, Factory Mutual Insurance are some of these big groups that really hire a lot of fire protection engineers to evaluate research, develop new research in order to keep progressing with all of the new materials and construction methods that we use in the field. Consulting is one of the biggest areas that we see fire protection engineers go into. And it's where you really end up working with the architects and the owners to develop, and as well as a multitude of other contractors and installers as you go, but to really look at the fire protection system, looking at the plans, you see a tremendous amount both in new construction as well as what I would call renovations, or an owner buying an existing structure and going in and renovating it. So lots of opportunity to make things fit, as well as what we always call a cost-benefit analysis, meaning one of the primary roles for the fire protection engineer would be to look at it and say, how do I get the best fire protection I can without going so overboard that we're breaking budgets and things of that nature. So kind of balancing the safety goals with the cost of it all. Industry is another place, and actually in some of the interviews we've recently updated our what we call career guide, so it talks about a lot of this in a little bit more depth and how to actually get into the field. But our industry reps that we've been talking to lately have some of the most fascinating careers, and they just keep saying, just keep trying something new. So when you're working in industry, this would be something along the lines of a manufacturing facility where you're on staff for the company, and maybe you're the only fire protection engineer on staff, but you oversee different facilities and new hazards that they bring in and new materials, as well as working in some instances globally, since many of the manufacturers have facilities around the world. So you then have to deal with different local jurisdictions in order to accommodate what their rules are and their laws are, as well as still maintaining that base level of fire safety. And I will say that's something that draws a lot of people into fire protection engineering, is that you have that additional piece of knowing you're doing something for public safety as part of your everyday job. So then we have government, which is definitely a primary focus on public health, safety, and welfare. And one of their big roles is enforcing the codes and standards that exist, and then also working towards some of the fire safe conditions within a jurisdiction. And a big challenge that a lot of these fire protection engineers have to work with is what happens when you have a situation, whether it's a space configuration or new materials or just something that does not fit within the standardized books, within our codes that are written right now. How do we deal with that, and what do we need to look at? So kind of just an analysis and evaluating the space so that you do get a good level of safety in there, even if the codes don't spell out exactly how to accomplish that. So, and then I just wanted to throw in a quick slide on credentialing. For fire protection engineers, it's really important, especially if you are working in the United States, to get your professional engineering license. So the quote that you see there actually just says, obtaining a professional license is important step in furthering your fire protection engineering career. It shows a higher level of commitment to the protection of the public and to the practice of engineering. So it really is that base level of minimum competency in order to make sure you're really there. So it's something to think about as you progress through academia and eventually reach the practicing point in your careers, that a professional credential is a big deal. And along that same lines, these are all little pieces of information that we've included in our career guide, which I believe next week will actually be available for download on our website. So. And that's the end for me.
Great. Well, thank you very much, Victoria. Really appreciate it. Very interesting. And so now is the time for the folks in the audience. If you have a question for our panelists about surveying or fire protection engineering or industrial or systems engineering, you can type it into the question area now. Thank you to all of our speakers. Really interesting to hear about some of the specific fields within engineering, because it's such a broad and complicated and wide-encompassing term. So we've got a couple questions. Ethan from Atlantic Shores asks a question to Scott and BJ. He says that he asks about the drones that you mentioned. Are they expensive, and do you make them yourselves?
I'm gonna push Ethan's question to Scott. I believe his office uses drones, and mine does not. Scott, you want to take this one?
You betcha. So we have done both. We have actually had a neighbor just driving home from work today. He had his garage open and stopped and talked to him, and he built us our first drone. We sat down and told him what we wanted. We were kind of apprehensive about buying one. It got a lot cheaper, and we crashed it an awful lot, learned how to fly with that one. Since then, we have just bought commercially, and they're not disposable, but we've lost a few of them, and they can be as inexpensive as $600-800, and they can go up a lot higher from there. And you know, you can probably start out a lot smaller. Anything that you can get a camera on and it'll hold a camera, you can about do it. But I would want to mention with the drones, when you start using them for a commercial application, you need to be licensed by the FAA. You got to go through a class and make sure you're certified and make sure everybody's safe. So hopefully that answers your question.
Thank you.
Scott, that's not the that's not a full pilot's license, correct? That's a certification for drone use.
Yeah, that's just a drone pilot's license that says, hey, if you're going to be flying this little drone, and I used to think it wasn't a big deal until you see how fast they go, and it'd really hurt if it hit you. So, and it could really do some damage if it hit someone in a car or another airplane or something like that. So, if you want to be a hobbyist and fly your own drone, you're good. But if you want to start doing and making a living off it, you got to play by the rules.
Great question. Thanks, Ethan.
Thank you. The next question is for Victoria. Doric asks, how can fire protection engineers help cities, either developing or developed?
That's a great question. So there are, I would say, a ton of different ways that you could help. So especially with a developing city, it allows for what I'd call better integration, in that you can really develop a plan for proper fire protection, and that includes everything from having active and passive materials in the structures themselves, as well as fire service response and how many firehouses and how many personnel would need to be utilized for response. And you'll also see a lot of developing areas use it to put buildings closer together and use then community green space, so that you're kind of giving a little bit of trade-off there. But the closer together buildings are, one of the goals of fire protection is always to make sure that a fire in one space is not really going into the next, and that especially applies when you're thinking about homes, which is common in community development and things of that nature. For existing, there's always ways to improve on some of the safety aspects, even if it's just lighting or new alarms that have appropriate sounds. There are all sorts of alarms out there, and there's a general alarm for the overall public, but if you have you know, for example, a nursing home or something of that nature, they have actually done studies to say that certain decibel levels are better for the aging population, and that's always a good thing to point out when you have you know, these types of facilities where you have a lot of older people in one area. So lots of different little features that can be used, both on a broad perspective and then when you get down to individual occupancies.
Excellent. Thank you, Christina. Victoria, sorry. Christina asks a question. She asks, how will your field change in the next 50 to 75 years, do you think? Charles, would you like to start, and then each person can answer it? How do you think that your field is going to be changing in the next 50 to 75 years?
Industrial engineering comes from a base of manufacturing, where 40 years ago, most industrial engineers were concerned with physically how to build goods and things. The need to be more efficient, to improve customer satisfaction, to improve on-time delivery of goods and services are really, I believe, where we are going to better satisfy the needs of the country. So I believe you're going to continue to see industrial and systems engineers move from manufacturing base toward making sure that the services and convenience people want in their everyday life are improved, that they get what they want, when they want it, seamlessly, and they do not need to know all the little pieces behind the scenes that get it to them. They're going to want what they have, what they need at that moment. So industrial and systems engineering are going to be moving more into services, more into using computers to analyze things instantaneously to changing how systems work, and it's going to be exciting.
Great, excellent. Scott and/or BJ, do you have an answer to that question of how your field will change, how surveying will change, you think, in the next 50 to 75 years?
We've talked about it several times as a profession. It's technology. You know, original surveyors, Abraham Lincoln, 3 of the 4 men on Mount Rushmore were all land surveyors. They had a compass and a tape measure, a chain out there walking and doing it. And now, with the advent of total stations and remote sensing and drones, it's just going to get smaller, lighter, faster, hopefully less expensive. But I think technology is really going to have a big impact on the profession of land surveying. BJ, what do you think?
Yeah, I mean, I completely agree. I mean, Christina, what a loaded question. I think it's difficult to say how we could forecast, you know, technology or how the profession of land surveying is going to change over the next several years. I mean, if you look back at how it's changed thus far, you know, since let's say since 1950, just leaps and bounds, right? I mean, it's immeasurable how much we've increased productivity, and not only productivity, but the quality of our product, as well as a safety aspect of things, you know, not only for the public and their land rights, but for personnel that survey employs, you know, with laser scanning and aerial and mobile LiDAR units, these kinds of things. I mean, it's safer for someone to scan an intersection than it is for someone to physically go out and measure angles and distances to the center of this intersection or an interstate highway or something of that nature. It's hard for me to say. I agree with Scott. I think it's got to be in the technology. It's going to get faster and lighter and more accurate. And it's going to lead us to places that, you know, I've been shocked this far. I think, you know, in the next 50 years, it's going to be pretty impressive. And I'll tell you, don't discount the amount of technology that goes into a smartphone. I think we're going to see some pretty impressive things over the next 50 years with what we use on a daily basis.
Great, excellent. We have time for 1 or 2 more questions. Blake asks Victoria, how would a fire engineer help elderly people stay safe in their home?
So there's a handful of ways that we can implement some of the things that have been around for quite some time. So one of the big things we talk about often is residential fire sprinklers, in that it's a technology that's existed in its own realm now since around 1980, but we still don't see a lot of areas requiring them. So it's really been a voluntary mandate for a lot of places. At this point in time, both Maryland and California have some requirements in place for new construction, but we still have a lot of existing homes and buildings out there without them. So I think that's probably one of the biggest components that can be implemented for elderly and the aging population. Most places already have some sort of smoke detector or fire alarm, which of course is also very beneficial. And then, you know, some of the passive measures. And then I also think just a general awareness. And I think that overall the public, irrelevant of age, still thinks that if a fire occurs, they've really got time to get out of their home, especially just because home always makes everybody feel comfortable. And that's actually a fallacy these days, where you've really got less than 5 minutes and most people think they have a lot longer. So residential is the big problem. That's still where we see the majority of our fire deaths. But there are some means out there already, as well as I think that there are things we haven't thought of yet and new technologies that could be developed that could come down the pike and improve that even more.
Thank you. So one last question for Charles comes from Dylan. He asks, for industrial or systems engineering, how long will it take to collect data and create virtual reality?
Now, kind of a loaded question there. It depends on the set of circumstances. We are rapidly hitting a convergent point where the hardware exists to provide virtual reality in almost any location. The bandwidth, we're going from 4GL to 5 within the next 24 months. The ability to distribute the information securely is existing. The problem is the number of bits of information necessary to project or analyze any specific installation. And that's going to be a challenge both on memory and on the number of locations. So I would answer to you this way. I think you're going to see it probably first happen in the medical suite. And if you want a hypothesis, you'll start to see superimposed virtual reality come into the medical suite and maybe even some high-end manufacturing in no more than 5 years. In terms of visiting remote places, in terms of collecting that type of information, a popular location, popular information, I'll go out on the limb and say between a decade and a half. To the point where we see the world, my friends here from surveying can probably tell you better than I, the world is a vast place. Collecting that amount of information is almost beyond my ability to project. Like many other things that all of us deal with, it'll be driven by economics. So the use of virtual reality to make work better, to make systems work more effectively, will go where life and money come first, medicine and high-end manufacturing, and then slowly it will affect our lives. One day it'll be somewhat like my grandfather, who once told me he grew up on a farm with an outhouse. He couldn't possibly tell me what the future had to bring. It's going to be exciting.
Excellent. Well, on that note, that's the amount of time we have for questions. Thank you, Charles, and thank you, Dylan, for the question. A quick announcement before you all head out. On October 4th at 4 p.m., same time, 4 p.m. Eastern, Future Cities annual theme webinar is going to be taking place. You'll have a chance to hear from experts about what age-friendly really means and how these kinds of cities are created. For those of you who know, this is the challenge, the topic for this year. We're very excited about it. If you haven't already, you can use this link to sign up now. The webinar will be recorded as well and posted in the resources section of the futurecity.org website, as will this webinar. So a big thank you to our 4 panelists who took the time out of their schedules to discuss their work with us today. Even though they can't hear you, why don't our whole audience give them a big round of applause? Thank you very much. We really appreciate it. It was very interesting. If you have any questions, you can email us at info at futurecity.org. Also, please take the survey that's going to come up at the end of the webinar. When the webinar's over, it'll come up, and the link will also be in the follow-up email that you'll receive. We'll try to tailor future events to cover the topics that you would like to see. So thank you very much for your time, and have a great day. Bye-bye.
Thank you, guys.